Hello everyone, and my name is Nichita, and the topic of my today's presentation is about the using of living cells to create supercomputers of the future. Firstly, let's start by comparison. Let's start by comparison one of the fastest supercomputers that exist right now, Tinhead 2, that can perform up to 54.9 quadrillion calculations per second, with the average human adult brain, which actually can perform on another level, with up to 1 quintillion calculations per second. And already based on these facts, we can say that actually using living system that exists today to solve problems that computers solve right now could actually bring a huge impact for development of technology in fields of science. And actually already many researchers create so-called cellular computers. But what is underlying factor that manipulates these so-called cellular computers? This comes down to the genetic information that is actually stored in the DNA molecule that is presented by a double helix structure with a combined between each other combinations of nitrogenous bases, adenine, cytosine, thymine, and guanine. Actually, interesting fact is that we can compare the DNA formation we've invented in 1936 computer system of Alan Turing, as both of this system, as you can see, perform their calculations on step-by-step basis using an infinite line with combinations of symbols taken from a fixed alphabet. So, the main goal of creating a DNA-based computers is actually to replace the traditional electromechanical processes with using only biochemistry and microbiology. In journal Nature, in 2019, was presented a first programmable DNA computer that was able with creation and different algorithms with DNA molecules to perform counting from 0 to 63 and multiply by 3. Even though this sounds like a simple experiment, but it opens up a stage for creating a so-called DNA-based robots. And actually in 2021, a magic DNA software was released that actually accelerates the process of creating these DNA robots by putting DNA structures into more complex structures. And researchers speculate that actually these robots will be able to create a microscopic technologies to detect disease-causing cells in your body and deliver drugs within it. Another approach of using DNA is actually to use it as information custodian, or simply saying to store large amounts of information on a small space, such as DNA molecule. In 2012, biologist George Church actually, with his team, encoded a 50,000-word book, 1 JPEG photograph, and even a Java program in a DNA molecule. And research showed that the density of information is actually 1 million terabytes per 1 gram of this molecule, while a traditional hard drive disk for 1 terabyte weighs about 100 grams. Another interesting thing is that actually researchers reported that you can extract information from DNA without using a single byte. That's why saying overall, of course there are many obstacles of creating a perfect DNA-based computer because the research is actually in the early stages of discovery and it is extremely expensive technology and actually of a little practical use right now, but if enough time will be spent and money on developing this technology, we will be able to perform calculations on a different level, on a much higher speeds with less energy spent. And this will allow us to develop new technologies in the fields of astronomy, physics, biology, medicine, chemistry, as well as advance our knowledge in study of artificial intelligence. Thank you very much, and especially thank you my mentor, Onkar Baines, for helping me with my presentation, and thank you everyone for listening.